circular motion. So now let's talk about the acceleration when you're in circular motion. This has a special name. It's called centripetal acceleration. Our learning target is I will analyze the concept of centripetal acceleration by exploring its causes, direction, and dependence on velocity and radius, applying these principles to real-world examples such as planetary orbits, vehicle turns, and amusement park rides. Okay, so an object in circular motion is always accelerating. Okay, so remember that the velocity isn't constant because the direction is changing, right? That's why it's always accelerating, because the velocity is changing. Remember, acceleration is the change in velocity divided by time. So the acceleration vector is perpendicular to the velocity and always directed toward the center of the circle. Thus the word centripetal. Okay. Calculating the centripetal acceleration of an object in circular motion. The formula for calculating the centripetal acceleration is acceleration equals the velocity squared divided by the radius of the circle. Okay. I would just like I did in the last video, I would show you how that came to be. But there are some geometries and stuff that are a little on the complex side. So if you're interested in learning mathematically how acceleration is velocity squared over radius, you can click on the picture and watch the video. I think they do a pretty good job of explaining it, but it's mathematics and we want to get to the physics of it, right? All right, so V is your velocity squared and R is your radius, okay? So let's look at an example, calculating the velocity, and acceleration of an object in circular motion. And then the question is, an object is spun around in a circle of radius 1.3 meters with a period of 4.5 seconds. What is its acceleration? Okay. First, we have to figure out what its velocity is, right? Because we need to know the velocity. So our givens are 1.5 meters is the radius and 4.5 seconds is the period. We can use those to find the velocity. Remember, the velocity is 2 pi times the radius divided by the period, which gives us 1.82 meters per second. Then finding the acceleration, we need to use that velocity squared divided by the radius. So 1.82 meters per second squared, our radius is 1.3 meters. And so our acceleration is 2.53 meters per second per second. All right, so let's sum it up, right? The acceleration vector points towards the center of the circle, and it's perpendicular to the velocity vector. And then for calculating the acceleration, A is equal to V squared divided by R.